So today we will be focusing on the logical design of IoT, and in that we'll be talking about the high-level concept of designing an IoT network. So far we have considered the introduction to IoT and then the physical design of IoT, and now we are going to proceed with the logical design of IoT. So in the logical design of IoT, we'll be considering the high-level representation of an IoT system, its components and operations. So in here, basically what we mean is that we'll be designing an IoT system before implementing it in the hardware. That means before physically implementing the IoT network, we need to do this logical design of IoT. So that is what we mean by this high-level representation of an IoT system. So in this logical design of IoT systems, the IoT designer has to consider these user requirements and overall objectives of the IoT system. So if a user wants an IoT system in a specific manner, the IoT designer must design the IoT system considering his requirements and the constraints in the environment, and also the possible objectives that can be reached with the available systems or available resources. So the logical design of IoT will focus on satisfying the design factors, including risks, requirements, constraints, quality of service, and assumptions, right? So basically, we'll be considering the risks, the requirements of the customer, the constraints in the environment, the quality of service we need to maintain, and the assumptions that we need to make in this design. So let's take, for example, a smart agriculture scenario. So in that scenario, once we are doing the logical design of IoT, we need to decide which type of sensors we need to take and which communication technology we can use to access the access point, and then the cloud, and from there onwards, the databases. And the user interface that we need to design must be considered, and also the database management, data storage, those things has to be considered. And also, if you are going to add security to the network, we need to consider about the security of the data and how the users can log into the system and use the data. So the difference between logical design of IoT and physical design of IoT is basically the logical design is proposing the high-level conceptual model of the IoT system, and the physical design is doing the hardware implementation of the designed high-level model. So specific implementation is done in the physical design of IoT. Then in the logical design of IoT, we will be defining the functional blocks that is required and the interactions between these functional blocks. So we'll be talking about this in the next slide. And the physical design will be doing the hardware and software implementation. And so basically, in the logical design of IoT, we'll be focusing on how the data will be collected from sensors and how the data will be passed through the different components in the IoT system, and how it will be forwarded to the customer and through the user interface, right? The physical design will decide which components to use and what softwares to use, in order to achieve that target. So that is basically the logical and physical design of IoT. Another thing is that the physical design of IoT will be doing the real world testing and debugging and ensure the system meets the required customer requirements. So the logical design of IoT consists of, we can basically consider different, methods of designing a logical design of IoT. So three such uh, like methods of doing is uh, these three types. So functional blocks of IoT can be considered, and IoT communication models can be considered, and IoT communication APIs can be considered. So these, I mean, methods can be considered and applied in our logical design of IoT. So if you have any questions, please ask in the chat, or else you can ask. The functional blocks of IoT will actually consider what are the basic functions that are required from an IoT system. So basically, once we take a certain IoT network or IoT system, that IoT system consists of devices at the edge of the IoT network. And then it will have communication capabilities, a communication medium to send the data from the IoT edge devices to the server. And it will also have security aspects, security features, which will enable the data to be secured and not accessed by other hackers or jammers who will erase or modify the data. Then we need a management system of the data, for example, and we need to keep the data in a secure manner in a database, and we need to manage all the access and sharing of the data securely with the customer. And also our IoT system should give some services to the customer. So based on the required services of the customer, we need to decide which services to provide. And then the application is the kind of the website or the mobile application which will be used by the customer as a user interface, which will enable that person to view the data, analyze the data, and control the output, or control or give some responses about the output. So that was basically about the functions that are commonly used in IoT systems. Next, we are going to talk about this IoT communication models, right? So IoT communication models means like what are the general communication models that are used in IoT communications, right? So in here, we are going to be talking about how, for example, a client is communicating with a server. So there are basically 4 methods that are in generally popularly used. So a request response method, publish subscribe method, and push pull method, and exclusive pair method. So we will look into them one by one. So request response model. So request response model. So can you name the protocol that we discussed last time, which used this request response model? Yes, HTTP. So HTTP method is using this client server based model, and it uses the request response communication model, right? So the client will send a request, and the server will receive the request. Once the server receives the request, the server will um, process the request, and then it will look and fetch the necessary resource from a certain database or a certain like storage of storage which contains the resources, which could be like supercomputers, and fetch the necessary resources that is required, and prepare the response and send back the uh, response to the client. So this is basically the request response communication model. So HTTP is one of the protocols that is using this request response model. Next, publish subscribe model. So can you tell me a protocol that is using that model? Yes, MQTT. So MQTT protocol is basically using publish subscribe model, right? So in here, the publish subscribe functions are done, and the clients can behave as either a publisher or a subscriber. So depending on the task. So if this is a publisher, uh, that publisher can publish to certain topic A and B, right? So it could be two different topics. So the publisher can publish at those two different topics based on the data it collects. And the subscribers who have subscribed to that topic will get the data from the broker, which is in between this publish and subscriber uh, clients. And this broker is a server who will collect the data and store the data in a list under each topic, right? So under each topic, the broker will list down what is the data that the broker has received. And then the subscriber will get the necessary data from the broker. So that is how basically the MQTT protocol works, and it is following this publish subscribe model. Then we have this push pull model, right? It is an advanced version of the MQTT protocol where we work with queues and data managing in the in-between server. So the publisher and consumer in here, publisher and consumer in here means again something similar to the subscriber as before. So this consumer is taking data from this server in between. If we take it as the MQTT protocol from the broker, and it is collecting the data in a certain rate from the data queue, right? So there's a data queue here, right? So the publisher is pushing data into this queue. So that is why it is known as push-pull model. So push function is done, and then pull function is done by the consumer. So publisher will, send data, and the broker who is in between will collect that data and keep that in a queue. So the broker will store that data in a queue, and the subscriber will pull the data from that queue in a certain rate. So the push and pull functions are independent. They could be using the same rate or else different rates to push the data or pull the data. So actually, protocols like AMQP, Advanced Message Queuing Protocol, use push-pull model. right? So you can refer about that. So that protocol is using this push-pull model, and this situation is happening mostly in situations where we have large amounts of data at the publisher side, and the publisher is sending large amount of data to the broker. So in that case, the data has to be queued in the queues and sent to the clients in a favorable rate to the client. So the client might not be like resourceful enough to get the data in the fast rate as given by the publisher. So therefore, the client might only need it in a small, frequency, and therefore he will pull it in a different frequency. Next, we will discuss about this exclusive pair model. So exclusive pair model is similar to the WebSocket protocol based communication, right? So it is based on, exclusive pair model is used in the WebSocket protocol, and so in there, basically, initially, a client will connect with the server, and the connection will be established between the client and the server. So in the initial handshake stage, where the client will communicate with the server and the server will communicate back with the client, where the handshake will inform the client about the parameters uh, which will be used in the communication, and so on, will be done using HTTP protocol actually, right? So this handshake will be done using HTTP protocol. So after that, after establishing the communication, this bidirectional communication will be done using the WebSocket protocol, and this communication will run until closed closed command is given by one of the devices. So the uh, this protocol is basically used for long uh, long communications, where we need to keep a lot of data in our communication, and we want to have real-time communication with the other device. In this case, the client, once it sends some data to the server will instantaneously view the data. The server also will instantaneously react to the data that the client has sent, and the communication will go in that bidirectional format, and it will be happening in the full duplex communication method. So after that, the communication will be closed if one of the devices decide to close it. So next, we will be discussing about the third category of the logical design of IoT, which will be about the IoT communication APIs. So, when we are talking about APIs, so let's first talk about what is an application programming interface, right? Which is an API. So, an application programming interface is basically uh, an interface that defines the standard and rules for two programs or softwares to communicate with each other, right? Basically, different softwares have different functionalities. So they are programmed to work for certain application and for a certain to give a certain output. However, like since those softwares are different to each other, uh, there should be a standard on how they should connect to each other. So those standards are given by this API. And so once we take an example for example of this API and how it works. So once a device or a user access a certain browser, for example, using HTTP protocol, then they send a request to the website, right? So that request is received by this API first. So the API is first checking what kind of request has been sent, and based on that request, API determines like which apps should communicate and how they should communicate. And based on that, API will access the necessary resources in the servers. Right? After getting the output, the API will send the response back to the user in the requested in the output in the format that the customer requested. So similarly, we can consider this in an example. So once we consider an example where a customer is ordering some food, right? The food will be ordered, via the waiter. So the customers will make the order, the waiter will take the order, and waiter will access the kitchen, and kitchen will do the necessary like task between ingredients, and then it will make the food that is required by the customer. Then the waiter will take it back to the customer in uh, the requested manner. So likewise, so similar to this scenario, the API will function. So in IoT scenarios, IoT systems will be using mostly some like popular APIs. So a type of API that is mostly used is like representational state transfer API, which is known as RESTful API. So these RESTful APIs are using like multiple apps together to give a very high quality service to the end device. Right? So the popular apps which are using the RESTful API are like Google Maps, Facebook, Uber, YouTube, Twitter, Google, and so on. So once we take, for example, this Google Maps is working. It's giving us some information, right? So once we give a request to find us, for example, our location, and also find us where the nearest shop is, uh, nearest store is, then the Google Maps will interact with multiple apps, and it will give us the necessary data we need. So the Google Maps will have connections between the storekeepers apps, and also the prices and the details regarding the prices, and those kind of apps. Likewise, it will give us the different services, and it will connect different services together and give us a final output. And so likewise, the RESTful API is used. So a RESTful API is basically running in this manner. So the RESTful API is accessed by the client. So the client will send a HTTP request, for example, and he will use the certain commands that are available in the HTTP protocol. So we talked about the get, put, post, delete function, right? So in the last class, we learned about this, right? Get, put, post, delete. So they can give this command, and then in the rest of it, in the rest of the request, they can mention the data that they require in the JSON or XML formats, right? And once we give it in that format, the HTTP server will authorize our request and access the databases and access the resources, right? So the resources will be accessed, and the representation of the actual data will be given to us. Like a copy of the actual data will be given to us. So that is known as the representation of data. So the representational state transfer is working like that. So basically, we will be sending a request to the web server in a certain specified format. So in that format, we'll be having first the URL that we want to access, then what is the method that we want to use. So if we want to access some, some kind of a photo or some kind of other resource, we have to use the get method, right? So a certain, method is there to use this method function. So that will be defined by the HTTP protocol. So we only need to give the URL and the resource we need. And once we give the resource we need, the web server will know what is the resource we request. Then it will produce the request, the response, and it will give the response back in the format of JSON, XML, and so on. So these are actually like uh, I mean kind of coding methods which are used to build websites. So JSON methods and XML method, HTML methods are used to build websites and code the websites. So in those kind of programming languages, uh, they structure the data in a certain format such that the viewer is able to observe that data in a website. So next we will talk about the second type of API, which is the WebSocket based API. So the APIs which use this WebSocket protocol is known as this WebSocket APIs. So basically what I mean is that the APIs which use applications such as chat boxes are using this WebSocket based APIs. So for example, if we go to an online web store which has the chat box uh, option, they will be using this WebSocket based API. And also these WebSocket protocol, I think I explained before. So they are also used in online gaming and real-time activities with the server. So basically, there are several like differences that we can see in the APIs that we discussed. So basically, the REST API and WebSocket API. Once we consider the REST API, the REST API is like a simple API when compared to the WebSocket API. So WebSocket API is a memory consuming API. It will uh, it will store all the data that is passed from the client to the server during the bidirectional long conversation. I mean, long connection that it establishes or keep on with the client. So it will have to store all the data that it communicates during that period. However, the REST API is basically using the request response model. And therefore, once the request is sent and a response is received, the connection is terminated, right? So after a request is sent and a response is received, the connection is terminated. So only the data during that request response model communication will be stored. Otherwise, they will not be consuming a lot of memory. So therefore, it will not use a lot of data as the WebSocket API, right? So likewise, in complexity wise, actually WebSocket API is complex than a REST API. However, WebSocket API is also required in situations where we require chat applications and we need to communicate with the server in real time, right? So I will ask you to go through these questions later. First, I will try to show you the rest of the content. So in here, I propose you to actually go through these references regarding MQTT protocol and APIs and HTTPS methods. So MQTT has some like some more details. I mean, this YouTube videos and the playlist has some more information about MQTT. So I think you can infer that and get more details. Apart from that, if you want to get good idea about the API, you can refer this video. And HTTPS, right? So how it works is also given in this video. I will also, I think, explain more about the security mechanisms about the HTTPS in this class as well. So in the last class, I think we discussed about the security mechanisms. So we had some concerns about this HTTPS and how the function of the asymmetric encryption is done and the symmetric encryption is done. So I would like to explain that again in this class. So basically, the HTTP method is using the control message stage first, and then it will use a data transmission stage. So in the control message phase, they will first establish the communication with the client, right? The client and server will establish communication between them during the control message phase. So the step 1, 2, 3 basically are for the control messaging stage. So first, actually, the client will um, send a TCP handshake stage means like the communication establishing will be done across the TCP layer, and like messages for synchronization will be sent by the client to the server. So synchronization messages will be sent such that the server will know with how to synchronize with the client, how to synchronize with the client and send data synchronously to the client. Once the connection is established, so uh, the key sharing will be done. So it will be done by sharing the public key with the client. So the public key will be first shared with the client, right? So the client will check the public key, and the client will uh, create a key called the session key, and the client will encrypt the session key using the public key that was shared by the server. And then that encrypted message will be sent to the server, and the server will decrypt that using the private key that the server has. So once this decryption is done, the session key will be available to the server, and that session key is now available for both the client and the server, right? And the client will send data, right? Uh, I mean, client will send the data by encrypting using the session key. And since the server knows that session key, the server can decrypt that data using the non-session key. And likewise, the same key will be used for the encryption and decryption in the data transmission phase by the client and the server, right? So the same key, once you are using the same key for the encryption and decryption, it is known as a symmetric encryption. Once you are using different keys for encrypting and decrypting, you are calling it as asymmetric encryption. So in asymmetric encryption, the public key will be used to encrypt the data, and decrypting the data will be done using the private key. So using two different keys for encrypting and decrypting is known as this asymmetric encryption. And the symmetric encryption means using the same key for encrypting and decryption. So I think you asked about the MQTT protocols, I mean security mechanisms in the last class. So I mentioned that in very constrained scenarios, we don't use much of complex security mechanisms, since we don't have the resources to give the clients the access to, I mean, authentication and, encryption and so on, right? But security mechanisms are available like for other scenarios where you have the resources to authenticate your devices and enable security in your system, right? So in such kind of cases, we can have different security mechanisms. So in MQTT, we have such security mechanisms, and there could be more than these security mechanisms as well. So basically, in here, I am presenting two basic security mechanisms. Right? There could be some more security mechanisms as well. Right? So in here, actually, first kind of a security mechanism will be, first one is about the secure broker. Right? So in here, actually, the broker is a very trustful device. We can trust the MQTT server. It is not a public one. It is a maybe our own computer or a laptop. Right? We can trust that device. It is in our own network. We know who's using it and who's delivering its data in. So we have the publisher and we have the subscriber in this situation. And in here, we will be sending our data to the broker, and the broker will decrypt the data, right, and send the decrypted data to the subscribers, right? So the data will be encrypted here, right? So in this one, actually, encryption means only the payload will be encrypted. So only the data is encrypted. The topic will be visible. So the broker, since the broker needs to have the understanding about the topic will be not encrypted. Only the data regarding that topic will be encrypted. So after so in this trusted method, the broker will decrypt the data. Decrypt the payload, right? And the broker will send that data to the subscriber. So in here, actually, since the broker is trusted, the data will be sent to the subscriber in a trustful manner. So the data will be sent to the subscriber, and we can consider that it is a secure scenario there. So in a situation where we use a public broker, the public broker might not be secure. In that case, we encrypt our data, and we don't let the broker decrypt the data in between. And we send the data to the broker, and the broker will not decrypt the data the broker will directly send it to the subscriber. The subscriber will decrypt the data using previously known key. So we assume that the key is previously shared with the subscriber, and the subscriber will decrypt the data with the key. So in the unsecure broker situation, the data will not be decrypted using the broker at the broker. So second method is actually safer than the first one. However, second method is more complex than the first one because second method requires us to share data of the key between the publisher and subscriber, and therefore more messages need to be sent when when that communication is done. That is one thing, and another thing is that if like huge amount of subscribers are there in the system, then each subscriber has to know this key. So that communication has to happen before like setting up the MQTT protocol communication between this publisher and subscribers. So the second method is safer than the first one, right? So it is so the broker is unsecure. So the in here actually this method is more secure. The total communication between the publisher and subscriber is done through encrypted data packet communication, and it is done through an unsecure broker. So that means that even if this broker is secure or unsecure, this communication will send encrypted data from the publisher to the subscriber. So it doesn't matter whether this is secure or unsecure. But in this situation, we have known beforehand it is a trusted or secure broker, and therefore we have sent it without encrypting to the from the broker to the subscriber. However, we cannot sometimes determine whether our MQTT broker is a trustful device or not. In that case, we can, it's up to the, person who's, implemented this. So they can decide whether this is the MQTT broker, whether that MQTT broker is unsecure or not. And based on that, they can use the optimal method. So in the second one, from the broker to the from the second one, from broker to the subscriber, the data sent is it's not encrypted, it's encrypted. In here also we are sending the encrypted data, same data that it received. The payload will be unencrypted. Sorry, encrypted. Payload will be encrypted. Right? So in here, from broker to the subscriber, payload will be unencrypted. So the original data will be sent as raw data from the broker to the subscriber. So I hope that is clear. And then when we talk about the security mechanisms in the CoAP, Constraint Application Protocol, the Constraint Application Protocol is using the UDP protocol, and on top of it, CoAP is built. So since we are using UDP protocol, we are using data packets to transmit datagrams to transmit our messages, and our datagram user datagram protocol is used. And in that method, we are actually not building a connection. We are not building a reliable communication with the client and the server, right? So in that case, our data packets might get lost, and then our data packets have to be retransmitted multiple times to its like neighbors, and from the neighbors to the server for the data packets to reliably receive, I mean, to be received at the server. So in a situation where we actually have security issues, we need to use a mechanism to uh, make sure that the data is sent from the expected client. That means the server needs to know that the client to which it is communicating with is actually the legitimate client. That means if there's an intermediate person who's accessing the if there's an intermediate person who is trying to send connection requests and sending data packets to the server will check whether some data are included in that request, right? So first and foremost, the client will first send a request to the server, right? So and then the server will send some information, some information or some, I mean, it is known as a cookie, right? The server will send a cookie to the client. The cookie is a random sequence number, and the random sequence number will be shared with the, I mean, to the client using the UDP protocol, right? So the client, once it receives the data packet, right? Once it receives the data packet using the UDP protocol, that client will receive this cookie, right? So once it receives that cookie, that after that it can communicate with the server, right? So the cookie is sort of like the kind of like the um, kind of the password or the unique password that it can use to communicate or get access to the server, to get authenticated by the server. The server will check the data requests that it receives, and it will only allow the data packets that has the cookie that it had previously given to the to its client. So if there's an intermediate person who's sending data requests like without any previous request and sending like information without cookies, then those kind of user requests will not be considered by the server. Such user requests will be rejected by the server. So only the clients which use this CoAP protocol and who use this DTLS method to request data from the server, and also once sending the request, the client who has obtained the cookie and who has sent back the cookie to the server will be allowed to communicate with the server. So using the CoAP protocol, the client needs to, client can use the DTLS um, protocol to ensure the security of the communication and build a reliable communication with the server, right? So after the communication is built, the normal TLS communication based, method is used, where the key exchange will be done, and based on the key exchange, the communication will be done. So as I explained previously, the TLS will use the different keys, right? Asymmetric encryption and symmetric encryption will be done even in here. Only difference is that the client will send a request and the server will send a cookie back to the client. So that is basically done because this user datagram protocol is used, and uh, different data requests are coming to the server, and the server needs to identify which data packets to address uh, and which are the authenticated ones. So actually, basically in the next class, actually I will do about the enabling technologies. So currently in this week, I have done for the regular students up to that point, and that is why I have mentioned that. So we'll be talking about the rest of this, content related to this IoT enabling technologies and IoT domains and so on in the upcoming classes. Right? Sometimes the order might be changed, so I might start with maybe software defined networking in the next class. So that is one thing. So I would also like to share this video if it is possible to uh, share it. Actually,